Now, thinking about what's coming, where we're going to take a unit circle and put our angle in standard position and measure where it cuts through that unit circle and call the horizontal part the cosine and the vertical part the sine, then we can see if you wrap around an angle, say maybe you go around a full revolution before you do this angle, or maybe several revolutions, all that matters to the horizontal and vertical part, not how big the angle is, but just where the angle ends. So two angles where their terminal ray ends or terminates in the same place, we would call coterminal. So, for example, 45 degrees, if you were to go a complete revolution around, add that to that, right, you'd get to 405 degrees. 45 degrees and 405 degrees are much different angles. In this one, you barely turn, just an eighth of a turn around the circle. Here you go all the way around once, plus another eighth. So these angles are different, but they are coterminal. They end in the same place. So as far as the horizontal and vertical, where it cuts off the unit circle, as far as that's concerned, they're the same. That's why we care about whether or not angles are coterminal. Okay, if you're measuring angles in degrees, you could just add or subtract multiples of 360 to find other angles that are coterminal. If you're doing it in radians, let's say we have an angle of 5 pi thirds in radians. Let's see, where would that be? 5 pi thirds is 10 pi 6, so 1 pi 6, 2 pi 6, 3 pi 6, 4 pi 6, 5 pi 6, 6 pi 6, 7 pi 6, 8 pi 6, 9 pi 6, 10 pi 6, there's 5 pi thirds. If we want to find other angles that are coterminal, we could add or subtract multiples of a full circle, right, which is 2 pi in radians. So we could go backwards 2 pi radians and find another angle that's coterminal. That would be 5 pi thirds minus 6 pi thirds would be minus pi thirds. So what that tells us is whether you go all the way around in the counterclockwise direction to 5 pi thirds or just go clockwise to minus pi thirds, you have different angles, right? You've gone different distances along that circle, but you are terminating in the same place. So as far as the horizontal and the vertical related to those angles are concerned, that's going to be the same. You could go backwards a full another turn. So you could, now that you've gone backwards one turn, you could go backwards another turn. So minus pi thirds minus 6 pi thirds again. And now you're going to have minus 7 pi thirds. That's an angle where you do a complete revolution backwards or in the counterclockwise direction, and then another pi thirds, and you still terminate in the same place with minus 7 pi thirds. You can tell whether or not two angles are coterminal because if they're coterminal, the difference, if they're in radian measures, is going to be a multiple of 2 pi. So we could tell that 5 pi thirds and negative 7 pi thirds are coterminal if we subtract them. 5 pi thirds minus 7 pi thirds is going to be 5 pi thirds plus 7 pi thirds, which is 12 pi thirds, which reduces to 4 pi, which is a multiple, right? It's 2 times 2 pi. So the difference between the two angles is a multiple of a full revolution, so we know that they're coterminal. With degrees, it's just a multiple of 360, since in degrees 360 is a complete revolution. So let's say we have this angle minus 85 degrees. It would be nice if we could write that angle if we could find something that's coterminal with a positive angle measure. Well, that's easy. We just add 360 to this until the angle becomes positive. So negative 85 plus 360 is going to be 360 minus 85, which is 275 degrees. So that just tells us that minus 85 or 275, they're different angles. One of minus 85 goes clockwise, 275 goes counterclockwise, but they do terminate at the same place. So if you turn backwards minus 85, you've almost gone backwards minus 90. Or if you go forward 275, there's 90, 180, 270 plus an extra 5 degrees. Two different angles, but they end in the same place. We want to find here two positive and two negative angles that are coterminal to minus pi thirds. So if we want to find positive angles, and we're at minus pi thirds, we ought to add 2 pi, right? So minus pi thirds, 2 pi is the same as 6 pi thirds, so we get 5 pi thirds. There's a positive angle that ends in the same place as minus pi thirds. We're supposed to get two of them, so I'll take my 5 pi thirds and I'll add 2 pi again. Again, 2 pi is just 6 pi thirds. So I find another angle that ends in the same place. 5 plus 6 is 11. So 11 pi thirds. I also want to find some more negative angles, so I can just subtract a full revolution. So if I take away 2 pi, that's going to be minus pi thirds minus 6 pi thirds, which is going to be minus 7 pi thirds. There's another coterminal angle. And from there, I can find another one by taking away 2 pi, that's 6 pi thirds. Again, gives me negative 13 pi thirds.